Welcome everyone to another meshing tutorial. Today we're going to cover different sets of panels that are overlapping, intersecting, a panel within another panel, and a panel with a hole. Right here I have two sets of overlapping panels. Let's take a look at the dimensions. If I go to the top view and display the dimensions, and of course I can display dimensions because I already set some dimensions in the CAD details. If I go to the CAD details with this tool, I can click on each joint to see the dimensions. If I go back to the geometry window, I can display those dimensions using this tool here. I can see that both of my panels overlapping on the top have the same dimensions, while the panels that I have at the bottom, they are different. One panel is bigger than the other. Now let's take a look at the properties of these panels. I'm going to turn off this option for the dimensions, and I will go to the panel element tool. I can see that I have a thickness assigned of 0 for each panel. Mesh densities are 6, seed density 1, and quad weight percentage 50. There's a tool in SFrame that allows the user to split intersecting and overlapping panels. If we go to Mesh and click Split Intersecting Meshable Panels, we will see how SFrame comes with a new configuration of panels. As you can see, this panel, for some reason, is winning over this panel. So the dimensions of this panel decreased. The same goes for this panel. For some reason is winning over this smaller panel. Some of you may think that the size has something to do with these panels, and that's the reason why the dimensions stay the same. The truth is that it depends on the thickness and the size. Let's give you an example. If I go back and I undo, I can still have my original configuration of overlapping panels. And now I'm just going to change the thickness to 1. And I will assign the thickness to the panels that lost against the bigger panels. In this case, both were the same dimensions, but I'm just going to assign 1 millimeter thickness, and for this panel as well. Now if I display my thickness, I can see that this panel is 0 and 1, 0 and 1. If I go over the same process, Mesh, Split Intersecting Panels, now I can see, in this case the smaller panel, in this case the panel on the right is winning over the other panels. So the thickness has something to do. But when it comes to dimensions, it will depend on which panel you created first. In this case I created this panel first, and that's why I was winning over the panel on the right. And why am I showing you all this? Because when it comes to mesh, once I'm ready to mesh my panels, you will see why. If I click the mesh button, and you will see this configuration for the shell elements that were created. I'm going to click no, and now I'm going to click the average the mesh density for all panels button to see the difference. Let's take a moment to see this configuration of panels. And now what we're going to do is mesh the original configuration we had with the same thicknesses. So I'm going to click no, I'm going to go back until we have this configuration. But now I'm going to assign zero thickness to every panel. Even if I click mesh, you will see some difference in the average mesh. Let's click no, and let's toggle this option off, and let's mesh once again. You will notice the difference here for the smaller panels and the bigger panels. I'm going to click no, and now let's proceed with the next example, a panel within another panel. Here I have a small panel inside a bigger panel. If we display the dimensions, we can see that one panel is 9 meters by 6 meters and the smaller panel is 3 meters by 2 meters. Now let's take a look at the panel elements and change to the top view. You'll see that we have a shell mix mesh where we have 0 thickness for each panel, mesh densities of 4 for the smaller panel, 18 for the bigger panel, same seat density and same quad weight percentage. I can see I have the average mesh density option on. I'm going to switch it to off. I'm going to mesh these panels, and after meshing I should see in the smaller panel 4 elements automatically generated for me, and in the bigger panel 18 elements the long span. If we mesh and something happened here, it's not giving me any warnings. I have some nodes without shells assigned to it. I'm gonna click no, and the first thing I need to check is the model tolerance. If I am in the geometry window, I'm going to File, Integrity Checks, and I can see I have a model tolerance of 1 meter, which is too high for my model. So I'm going to change it to 1 millimeter, and the same goes for the member length tolerance, and I click OK. Now let's take a look at the model. If I mesh it, it came with the right configuration. 4 elements for the small panel and 18 elements for the long span of the bigger panel. Now I'm going to click no, and I'm going to click the average mesh density for all panels. If I click, I can see my new configuration, which is an average of both mesh densities. For this example, since one panel is within other panel, we don't have intersection. I'm going to click no, and now let's go and see an example. If I set a thickness, first let me modify thickness only. Thickness of 30 for the inner panel and a thickness of 20 for the outer panel. Now if I view none and display my thicknesses, I can see that the smaller panel has bigger thickness than the bigger panel. I'm also going to assign different materials to each panel. So if I go to material properties, I will assign, right now we have material 1 for both, but I'm going to assign concrete for the bigger panel. Now you can see both are different. If I go back to the panel tool and click mesh panel and I accept these changes, what I can do is I'm going to hide the panel elements, and you will see why in a few seconds. If I go to select, unselect panel elements, I go to my quadrilateral element tools I can see I have my thickness being displayed. If I shrink my elements, for the smaller panel we can see the thickness 30, and for the outer panel we can see that is 20. The same happens if I go to material, and as you can see I have material 1 and material 6. Now let's proceed with the next example, panels intersecting. In this model I have 4 different panels that are intersecting. We have the bigger panel in the XZ plane and 3 panels in the XY plane. Now let's take a look at the properties for these panels. If we go to the panel element tool, we have shell mix mesh panels of 0 thickness. Mesh densities, we can see that for the 3 panels with the same dimensions is 6, and for the bigger panel in the other plane is 10. Seed densities of 3 and quad weight percentage of 50. Now let's try and split these meshable panels. But before that, let's see what happens if I click mesh. As you can see, it came with a fine mesh due to the average option, but I'm gonna click no, toggle this option off, mesh once again, and the individually meshed panels look like this. I'm gonna click no and proceed with the explanation. In order to see what happens, let's split these panels. If we go to mesh, split intersecting panels, you will see these panels have been splitted, and also mesh densities are different. Please note the meshing algorithm automatically finds the intersection of all these panels and splits them in different panels to ensure meshing consistency at the intersections. Also, the mesh density changes because the size of the panels change after the splitting operation. However, the algorithm tries to keep the mesh density the same as the original, which is unsplit version of these panels. We can also toggle this option off for the mesh density. We can also take a look at the local coordinates of each panel. Some of them are different, but one of the improvements in the next release will be that the end result of the meshing will ensure that the shell and panel elements will keep the original parent panel coordinate system. So every panel and every finite element as membranes, plates or shells will have the same local coordinate system. This type of operations, let me toggle these options off, the local coordinates. It is pretty important to double check your model tolerance if you go to File Integrity Checks and assign an appropriate model tolerance according to your model dimensions. If I mesh now, I will have the same mesh I showed before, since S-Frame locates those intersections automatically. I click no. If I average the mesh densities and mesh once again, you can also go to mesh panel elements, and I'm gonna accept this. You will see the final output. Now, if you would like to see the consistency of the mesh at panel intersections, there's a useful feature called hidden surface removal. But before using that feature, you will need to have the selection tool active in the geometry window. So if you click the selection tool, then we can proceed and go to options and click this option here, hidden surface removal. You will be able to see the consistency between the mesh. Where are the nodes that share the different shells for the panels located in different planes. And now let's take a look at our last example, a panel with a hole. For our last example, we have a panel with a hole. We have a 6 by 6 meters panel, and the hole is 1 meter radius, and there are 20 links along this circular hole. Just to give you an idea of how I created these panel elements, I'm going to switch to the top view, and I'm going to start drawing my panel. So we have a shell mix mesh panel, and we have a hole in this location. To draw that hole, I just need to go and change from shell mix mesh to hole, or I can even click here, color of the hole. So I'm going to select hole. I will specify a circular pattern. So you have a drop down list, circle, specify a radius of 1 meter and 20 divisions. I just need to click in this location and you will see the hole. Let's take a look at the thickness of this panel. I'm gonna get rid of this panel if I go and delete them. So here we have our panels, 100 millimeters, 250 millimeters, mesh densities of 3 and 25, seed densities of 3 for both, and quiet weight percentage of 50 for both. If I mesh these panels without the average mesh density button, it will come up with the following configuration. As you will notice, this configuration can lead us to a warning message for element of poor quality and potentially lead to less accurate local results. We will need to achieve a good ratio in each panel element. We can see the distribution of different sizes, how they are jumping. Let's just accept, and if we zoom in, we can see big jumps between elements, from these elements to these elements right here. These are too big and these are too small. Since I click yes, I can always go back and delete my elements and keep my original panels. So I'm not going to delete these panels, I still have them here, but if I switch to the quadrilateral element tool, I can see I have some quadrilateral and triangular elements. If I hold Ctrl and click and drag, I will get rid of those quadrilateral elements. Now if I go to the triangular elements and do the same, Ctrl, click and drag, I will get rid of the triangular elements. So I only have these nodes that are somewhere in our model, but I can delete them if I go to the join tool. Same way, hold Ctrl, click and drag to delete them, and I will have my original panel configuration. The issue could be related to model tolerance. Remember, I told you guys always check on your model tolerance. If I go to File, Integrity Checks, they are fine. So the issue should be related to the mesh properties. So let's take a look at the mesh densities. As you can see, there's a tremendous mesh density in the circle, and we have a small mesh density in our quadrilateral panel. So I'm gonna switch this mesh density, and I don't want to change the thickness. So what I can do is I can modify the mesh parameters only. So I'm not gonna modify the type or the thickness of my panels, only the mesh parameters. So I click and I select, let's say for our bigger panel, a mesh density of 15. Even though I have hole selected, it's not changing my panel element since I have only modified mesh parameters. And for the hole, I will select a smaller density, let's say 10. I click and drag, and now I will mesh this again, and I'm going to accept these changes. As you can see, we have a better ratio of our quadrilateral triangular elements. As you may note, meshing and generate shells, plates or membranes could be a tricky process, and this is why you always need to iterate in order to achieve the mesh you are looking for and to achieve more accurate results. If sometimes you ever struggle with this type of exercises, or if you are building a model using meshable panels and you find an issue or have any questions, please send us an email with your model to support@sframe.com, and we will be glad to assist. Thank you, and for more tutorials and videos, please subscribe to our YouTube channel.